Hi friends, welcome. Today in this lesson we'll be covering about linked list, counting number of nodes. So the idea of this programming interview tutorial is to help you ace your programming interviews by preparing you to solve the commonly asked interview questions. I am going to expect support from you people, so please subscribe to the channel, and I'll be planning to have one video per week. So let's get started today. Before we start with the session, I'd like to give you a brief introduction of a linked list just to help you revise the concepts. So when we say a linked list, so linked list is nothing but a dynamic data structure where we have multiple nodes which are linked to each other. So whenever there is not an explicit mention of whether it's a singly linked list or doubly linked list, it will be definitely a singly linked list. So now a node is basically a pair of data element and the next pointer. The last node is going to point to null, that is, therefore I have marked it like this. So when we say how will a node be represented as a class, so let's say class node. You can please forgive me for my handwriting, but yeah, so class node. Now the data can be any data, it can be string, it can be integer, so we are assuming it to be integer here. So int data, and then a pointer to the next element, so which will be node. So since it's a data element, so it will be pointing to the next element, which will again be a node. So they're only collection of nodes. If you see, they're linked together. And now why do we actually use linked list? I mean, you might be aware of this, I hope, because you're watching this video, but still, to help you recall why we use linked list is that it is a basic dynamic data structure. So the nodes are allocated at runtime, and we can create them on the go as in whenever you need to create the node or the element, you need to save the data item, you can create another node and then add that data item to the node, and then you can link it to the previous node, which is the last node of the linked list, or whatever would be the insertion order. It will really depend on that. So let's look at the code and how to do that. So let's get started. So this method is basically going to return a count, which is the number of nodes. Count get node count, let's name it as get node count, and it will take a pointer, head pointer, as an input. So what is a head pointer? Head pointer is nothing but something like the first element of the linked list is pointed by a pointer which is referred to as head. Okay, so this is the head node. Now it is going to take the head. Now we need to traverse the head and move to the last node in the linked list. So let's say node curr, which is the current node, is equals to head, while head is not equals to null. I mean, the current is not equals to null. Initially the current value is not null. Okay, current is not equals to null, count plus plus. So we will initialize one counter, which is basically going to maintain the count of the number of nodes, and then we will move the current to the next element, which is current is equals to current dot next. Okay, now we are going to return this count from this method. So this is the simple logic to count the number of nodes in a linked list. Let's try run this code. So let's try it on this linked list. So this would be our current node. We are pointing it to as C. Okay, just to simplify it. So current is C here. We have a current node. Now this is not equals to null. I will increment the counter and move this to here. that is current dot next. Okay, so the next of this is this. The counter is incremented to 1 by 1, so the value is now 1. Initially it was 0. Okay, now again this is not equals to 0, I mean the next, this is not equals to null. I'll increment it again, so the counter is 2. Again I increment it. Next, the counter becomes 3. And finally this is again not null, so increment it, and now this becomes null because the last element points to null, so this is null, so the counter has become 4. So we are going to return 4 as an output from this procedure. And if suppose our head empty linked list basically is being passed, so when we call as an empty linked list, it means it has no data items. That means the head points to null. Okay, so if the head points to null, that means the counter will be 0, and which will be the correct answer. So we have basically tested it for one of the cases which are corner cases. So whenever you are writing any program, you should make sure that it satisfies the corner cases, which is very important consideration while writing any code in an interview. So that's it for this session. I would expect you to please provide the reviews, and I'll try to add more lectures and improve the content on the go. Thanks all for watching this video, and please don't forget to subscribe and share your valuable comments and feedback. Thank you.